In this tutorial, I'm going to cover how to do MySQL snapshot backups using Holland and LVM. First things first, you need LVM. One of the things to note, I'm not really going to go through the specifics about how you would set up LVM, but I do want to highlight a few things. First thing is, you do need snapshot space to do the backup. Now, how much snapshot space you actually need depends upon the type of data, your write frequency, those sorts of things. In this case, I've actually allocated a pretty small amount, pretty large if you consider the actual size of my file system. But in a practical case, you'd want to allocate 15, maybe even 30 gigabytes for snapshots. The worst case is you have to grow the file system, something along those lines. So it's good to be a little bit liberal for that setting, but you do need at least some space. The second thing is if you're using an interesting and someone would argue superior file system like XFS or some other file system, you want to be careful about the mount options. XFS in particular likes to use UUIDs, and that tends to screw up snapshots, so you'll want to mount with a no UUID option. Finally, when you're using LVM mounts or some external drive of any kind, one thing I don't recommend you do is hard mount MySQL to that device. Now, if you're using XFS, which doesn't have a loss plus found directory, it's not a big deal. But if you're using ext3, loss plus found is going to be there. It's going to exist as a database, which is really kind of annoying. Plus, you can't use that LVM mount for anything else. Instead, you can see what I did here, which I created a MySQL-LVM mount, and under that I have /data, which is where my actual data is. I'm going a step further as well in symlinking the default location of MySQL, in this case for our libmysql, over to it. In terms of understanding, particularly if multiple people are involved in your config, this is really helpful because system-wide installs are in system-wide places, everybody knows where they live, really easy to sort of figure out what's going on. So kind of recommend you do that as well. Now once you have a working setup and MySQL is running off of it, the rest of it's pretty easy. We simply go and configure a backup set in Holland. Now there's a couple ways to do this. I recommend in this case you go ahead and pull from the examples directory. You can use the Holland mkconfig utility. There's less comments in that file, and actually I think some of the options are even out of order when you make that config. So go ahead and pull from the examples directory and you should square you away. There's really not a lot of stuff you need to configure for LVM backups. Of course, there's the stuff at the top which is common to every backup, and I'm not going to go through that here. It is covered in another tutorial if you're interested in what all this stuff means. I'm just going to focus on the MySQL LVM section. And for the most part, you're not really going to need to change anything, but just to go through some of the settings here. If for some reason you need a lot more snapshot space in Holland it's allocating, you can go ahead and put that size in here. Or if you wanted to set it less for some reason. You can also name the snapshot and mount point. This is sometimes convenient if, for example, you're running file system backups in tandem with Holland and you don't want them to run on top of each other. One thing, for example, that can happen is while you're running the snapshot, your file system backup kicks off and it starts to copy data from the snapshot. And while it's doing that, if Holland finishes, it won't be able to actually unmount the snapshot and you end up with this weird situation. So you'll want to make sure you sort of take care of that. By default, it's going to kind of generate something for you under /temp. Now, a couple of other options here is InnoDB recovery. By default, it's set to false. I would probably recommend in most cases you go ahead and leave that. What that essentially does is when you actually initiate a backup and it mounts a snapshot, the next thing it's going to do is going to bootstrap MySQL to run an InnoDB recovery operation. The idea there being the resulting backup is going to be a pristine copy of your data directory without having any sort of recovery options in place, so you can just unpack that thing, fire up MySQL, and you're done. In most cases, when you're doing a restore, InnoDB recovery is not going to really take that long. In extreme cases, though, that can actually cause performance issues if you do it at backup time. So unless you have a clear need to do that, I would go ahead and avoid that case. Now, two settings that are enabled by default, which is lock tables and extra flush tables, you're generally going to want to set those to true. There are going to be special cases where you might not lock tables, such as if you're fully InnoDB and you're not using binary logging or don't really care to make that type of backup. In that case, we can go ahead and mount the snapshot without actually acquiring a lock, which is kind of cool. But in most cases, you might be doing binary logging or have a mix of MySQL or InnoDB or some other engine. And it's important to grab that lock, because if you grab that lock, you basically make sure that any engine under MySQL should be able to be backed up using the snapshot without any issues. You also allow for things like point-in-time recovery or using those backups to, say, clone a slave or master if you're doing MySQL replication. The thing that we do, which is a little bit of a trick, is sometimes flush tables with read lock can take a while. Now, to lower that time in extreme cases, such as if you have an extremely large amount of tables, we actually run a flush tables before we run a flush tables with read lock. The idea there being is all the heavy lifting is going to be done in flush tables, so that when we get to the flush tables with read lock, it's not going to take quite as long, and the total lock time for the backups can be a lot less. In most cases, the lock's going to be maybe a couple seconds up to perhaps a couple minutes in some extreme cases. Not really a lot to worry about, so if in doubt, go ahead and leave those settings turned on. Compression works just like it did or does for any other providers. One exception to that is that we found LZOP tends to be really fast for LVM, particularly when you're on fast hardware. So you might try LZOP if you're really trying to get speed and trying to squish down the time that your backups run. As a side note to that, typically the longer the snapshot's mounted, the slower things are going to be. So, if you have a really, really long backup, it might make sense to pick something like LZOP at the cost of extra disk space so you can have that backup run faster and perhaps lower your performance penalty. We found it's a rough estimate, but typically when you're doing a snapshot backup, you're going to see a 30% hit on writes. So still a good idea to maybe run it during an off-peak hour, something along those lines. Now, what this actually looks like is once you've created that backup set, and if you want, you can add this to Etsy Holland, holland.conf, and make it a default backup set. But for now, I'm just going to run it on the command line. So I'm going to fire this off. And you can see it reads the config file, does some other things. In this case, you can see it noted that I have a binary log, or have binary log enabled. Also notice that I'm not a slave. If I was a slave, it'd also record slave information and would store that alongside the backup. So this is kind of nice. It is going to be in the backup set that gets created, but in cases that for whatever reason you don't have that, you can always look at the Holland log and it will tell you the last one that ran. Once we do that, you can see it did run a flush tables. Releasing read log was right there. Okay, this is the whole thing. There's no timestamps on this particular output, but just to give you an idea, it went actually really quite fast. The backup itself ran pretty well as well, about 30 seconds, which is not bad. Now, if I was writing the database during this time, I would have been able to do that unhindered, except for this time up here where I was actually doing the flush tables with read lock. Everything else would have been lockless, would have been taking a performance penalty, but still pretty good, all things considered. So I'm going to go take a look at this here. And you can see there's another backup set on the server already. That's because I ran this earlier today. I'm going to go look at the current one to see what it looks like here. And there's really not a lot going on. Unlike a MySQL dump, all you really end up with is a tarball with your compression agent. In this case, I was using gzip. An archive log, which is actually the output of tar. So, if you want to look at some specific information there about what tables might have gotten backed up, that's in there, as well as the config. Config's kind of nice because you can see right here at the bottom, I have the information that if I was cloning a slave or doing something along those lines, this information will be right here. Again, you can pull it from the log if you prefer, but the point is you don't need the log to get this information as long as you're backing up this somewhere safe, be it on tape or what have you. Now, this tarball is essentially the backup of the datadir in the datadir directory. So when you go to unpack it, keep that in mind that you might want to put that under a directory since it's just going to start pulling out files right on whatever your current directory is. You can also use the -C option for tar to put that in a directory if you'd like. That's really it. If you're going to do a restore, you unpack that, put that in your data directory, start MySQL up, and you're done. One thing to note about that, though, is that if you're going to be doing per table or per database restores, one thing you might notice is it's not terribly easy to do that with LVM. And in fact, if you're using something like InnoDB, you don't really have any choice but to uncompress the entire archive, bootstrap MySQL, pull out the data that you're wanting, if you're wanting just a single database or table or what have you, import that, and then be off and on your way. So if you think you're going to be doing a lot of per table or per database restores, LVM may not be the best fit. Perks about it, though, it's point time recovery. You get that essentially for free. Backups tend to be really, really fast. Restores also tend to be really, really fast. Backups aren't always as small as they would be for a SQL dump, but usually the trade-off in performance is well worth it. So that's essentially it. If you got any questions, you can definitely check out the wiki. There's a pretty good page on what backups, LVM backups are and how to configure them, what all these settings do. I recommend you take a look at that. There's also some quick steps on how to actually copy stuff over if you're wanting to do actually unpack the archive and things like that. So you can find that here. And as with most Holland things, you're going to find a lot of other useful information on the wiki as well, such as other providers, other video tutorials, things like that. In any case, I hope you found this helpful. If you have any questions, feel free to hit up our mailing list. And other than that, enjoy using Holland.